Okay, so now we're going to move along and we're going to talk about a very specific function. We're going to talk about the quadratic function, which we've seen before in grade 10. So today we want to focus on finding the vertex through of a quadratic through factoring or partial factoring. So factoring we've been doing all along. That's not new, but partial factoring will be new to us. And no worries though, it's not a hard concept. Okay, let's start with a bit of a review of the quadratic. So here are two examples of my quadratic function. It can either open up or open down, which means you can have a minimum or a maximum. So let's begin by just labeling these quadratics. First off, your vertex. Your vertex is your lowest or highest point on your quadratic. So for example, right there could be my vertex. So let's name that vertex. Or up here could be the vertex. So let's name that the vertex. So it's your lowest or your highest point. Next comes your zeros. So your zeros are actually just your x-intercepts. It is where your parabola will end up crossing your x-axis. So those, another name for those is zeros. It's actually also called roots. So, I mean, there's three different names for the same thing. It's zeros or roots or x-intercepts. It all means the same thing. It's where your parabola crosses on your x-axis. Now notice that if you examine your two zeros, what you should see is that everything is symmetric. It is exactly, those two zeros are actually exactly the same distance from the vertex, right? Kind of splits in two. And that's because all our quadratics are symmetric. In fact, the line that cuts it in two has a special name. That's called our axis of symmetry. Our axis of symmetry is the line that cuts through the parabola exactly in half. Okay, so that's an axis of symmetry. If you have a lowest point, then it is a minimum. Whereas if you have a highest point, it's called a maximum. And then our y-intercept is wherever the parabola crosses on our y-axis. That's our y-intercept. So that one would be there. And then over on this first graph, it would be down here at -3. Okay, so lots of good things to remember about the quadratic. Now we want to find the vertex, so that's either our lowest point or our highest point. I'm going to show you two methods. Method one is factored form. So if you want to take a minute and pause this right here so you can copy this down. But really it's telling us that we can use our x-intercepts to help us find our vertex. Because they are symmetric with the parabola, it means that they're an equal distance from the vertex on either side. So if we have factored form, we can put each of the factors equal to 0 and then solve for x. Once we have those two factors, those two zeros, then we can find the midpoint between them, and that will be the x-coordinate of our vertex. We're going to sub this value back into the equation, and then we can determine the value for y. So let me show you how this is done. Let's take a look at this example. Determine the vertex of the parabola f of x equals x minus 1, x plus 5. So this is already in factored form for us. You want to take each one of these factors. Oh, sorry, I don't need my brackets anymore. I'm going to take each one of these factors and set them equal to 0 to solve for x. And I get x equals 1. And I get x equals -5. All right. So now we're going to have to use our midpoint formula. We should remember that from grade 10. Midpoint formula is really just an average formula. It tells us that if we take our two values, so we had a 1 and a -5, and we add them together and divide by 2, then that gives us the midpoint, in which this case is -2. So that means of my vertex, of whatever this looks like, let me just draw a quick little graph. We had a 0 at 1 and we had a 0 at -5, that my vertex, my x-coordinate of my vertex must be right here at -2. So that's what that -2 means. So my vertex is at -2, comma something. So we need to figure out what that something is. And the way to do that is take that -2 and put it back into your function. So we're going to find f of -2, which means I have -2 minus 1, -2 plus 5. F of -2 equals -3 times 3, which is -9. So therefore, my vertex must be at -2, comma, -9, which would be, let's say, here on this graph. Okay, so factored form, take your zeros, find the midpoint between the zeros, then take that number, plug it back into your function. So let's try, let's try another one. So here we are. This one's not in factored form, so we're going to have to go ahead and actually put it in factored form. And to put this in factored form, I'm looking for two numbers that multiply to -32, but add together give me -4. And those two numbers are going to be a -8 and a +4. Okay, now that it's in factored form, I take each one of my factors and set them equal to 0 to solve for x. So I have x equals 8, and my other 0 is going to be x equals -4. All right, now that we have our zeros, we need to find the midpoint between them. So I'm going to add those two zeros together and then divide by 2, which is going to give me 4 over 2, which is just 2. Okay, so that's the x-coordinate on my vertex. I need the y-coordinate on my vertex. My last step then is to take that 2 and plug it back into my equation. Now you can pick. You can either do the standard form equation, the one without the brackets, our original, or you can do factored form. It's up to you what you would prefer. I'm going to do factored form, I think. So 2 minus 8, 2 plus 4, which is going to give me -6 and +6, which is -36. So in this case, my vertex is at 2, comma, -36. All right, here's another one for you to try. So pause the video right here and try this one on your own, and then come back and see the solution. All right, so hopefully you were able to figure this one out. I'm going to start by factoring this. So two numbers that multiply to -48 but add together give me 2 are going to be a +8 and a -6. And then I'm going to take each one of those factors and put them equal to 0. And I get x equals -8 and x equals +6. Okay, so let's add these two zeros together and divide by 2. And I end up with an x-coordinate at -1. And now I'm going to take that x-coordinate of -1 and I'm going to sub it into my factors. And I get -1 plus 8 and -1 minus 6, which is going to be a +7 and a -7, which is -49. And so my vertex is at -1, -49. Okay, I feel like you're probably getting the hang of this. You factor it, take your zeros, find the midpoint between the zeros, take that number, and put it back into our function to get our y-coordinate of the vertex. All right, but what if my factoring skills are not so great and I want to try to get the vertex in another way? So here we go. Another way, oops, should not be called completing the square. So I apologize for that. that it should not be called that. It's actually called partial factoring. So I must have forgotten when I was switching up my slide. So let me change that right now. Partial factoring. There we go. Sorry about that. Okay, so pause the video here to take the notes. But not all quadratics have x-intercepts, so we need another method as well. And one method that we're going to use is called partial factoring. So the first thing that you need to do is make sure that your function is in standard form, which just means no brackets. We cannot have any brackets of any kind. Then from there, to find the x-coordinate of the vertex, we're going to use the equation, not equations, it should be just to use the equation, of x equals negative b over 2a. That gives us the x-coordinate of the vertex. From there, we're going to substitute it back in to the actual equation to get our y-coordinate of the vertex. So let's talk about that. Here we are. So we have determined the vertex of the following: x squared plus 6x plus 5. We could factor this, but we're not going to. I'm going to show you how you do this with partial factoring. So partial factoring. It's really quite simple. So we have x equal to negative b over 2a. This is going to be our big formula that we're going to use in order to find the vertex. And when we do, this is what we get. The value in front of your x squared is considered to be a. The value in front of your x term is considered to be b, and your constant is considered to be c. So in the expression x squared plus 6x plus 5, a is 1, b is 6, and c is 5. So if I'm looking for my x-coordinate of my vertex, I'm going to take a negative b. It just means take whatever value you have for b, which in this case is a 6, and change its sign. So it's going to be a negative 6 all over 2 times a, and a is 1. So negative 6 divided by 2, which is negative 3. So the x-coordinate of my vertex is at negative 3. And then from there, I want to find my y-coordinate. And my y-coordinate is going to come from plugging that negative 3 back into my original. And if I do that, I get negative 3 squared plus 6 times negative 3 plus 5, which is going to be 9 minus 18 plus 5, which is negative 4. So my vertex then is going to be at negative 3, comma, negative 4. All right. So let's take a look then at a couple more examples. It's just a matter of having them in standard form, and then from there, taking that negative b over 2a, that gives you your x-coordinate, sub it back in, and get your y-coordinate. All right, here's a few for you to try. So I'll put all 3 up here so you can see. There you go. I'm just going to go ahead and solve them, but feel free to pause this right here, right now, so that you can try them and then come back. All right. So I'm going to start with my x-coordinate. Remember, it's negative b over 2a, which is going to be a negative 16, so positive 16 over 2 times 2, which is 16 over 4, which is 4. So my x-coordinate of my vertex is at 4. And if I find f of 4, I get 2, 4 squared, 16 times 4, minus 3. So 4 squared is 16 times 2, which is 32. And then 16 times 4, which is going to be 64, minus 3, which is negative 32, which I think ends up as negative 35. I'm just doing some mental math here, so hopefully I'm right. So this means my vertex is at 4, comma, negative 35. All right, over here, same thing. My x coordinate is negative b over 2a. So this is going to be a negative 60 over 2 times negative 5, which is negative 60 over negative 10, which is just 6. And now all I have to do is plug that 6 back into my function. And I get 36 times 5, negative 5. I think that's 180, so negative 180 plus 360 minus 4. So that's negative 180 minus 4, so negative 184. So 6 comma negative 184 would be my vertex. And last, I have, once again, negative b over 2a. In this case, it's going to be a negative 5 over 2 times 3, which is negative 5, 6. So I get it. We have a fraction. We don't like fractions. But I'm going to ask that you actually try to keep them. If it becomes a serious problem and you absolutely can't, then change it to a decimal. But for the most part, I would prefer for you to try to keep the decimal or the fraction as a fraction. All right. So negative 5, 6 squared is 25 over 36. And this is going to be negative 25 over 6. And so this becomes 75 over 36. I'm going to change this so it's 36. So I have 25 times 6, which is going to be negative 150 over 36 plus 36 over 36. And now that I have a common denominator of 36, 75 minus 150 is negative 75 plus 36, which is negative 39. Both of those can be divided by 3. I can see that right away. That gives me negative 13 over 12. So negative 5, 6 over negative 13 over 12 ends up being my vertex. So that one's definitely harder because of the fraction. But I ask that you try to keep your fractions. All right. So partial factoring and factoring can give us our vertex. So important. This will definitely help us as we move along into some word problems coming up. All right, homework, page 31. Not a whole bunch, but give these a try. Practice it because we're going to need to know how to find our vertex when it's not given to us so that we can answer some word problems, which will be our next lesson. Thanks.